Now we have question number 4, and this question number 4 is about the same example that we were discussing, similar example that we were discussing in the previous question, that a farmer grows silver carp in 3 types of culture systems, that is intensive, pond 1, semi-intensive, pond 2, and extensive, pond number 3. And he measures the condition factor for comparing the growth performance in the 3 conditions. And these are the observations that he made. And there are 2 classes for the condition factor less than 1 and condition factor greater than 1, and these are the observed frequencies. Now the question is, find out if there is an association between culture system and condition factor of fish. These are the expected frequencies that we calculate by the formula which is used for the chi-square test of independence, the row total multiplied by column total divided by grand total, and this has to be done for each of these 6 cells. So the first cell, which is for the fish with condition factor less than 1 in pond 1, the expected frequency is 35.91. Then in the next cell, which is about the fish with condition factor less than 1 in pond 2, this expected frequency is 26.69. Then in the next cell, we have the fish with condition factor less than 1 present in pond number 3, and their row total is 75, their column total is 99. So they are multiplied, and then their answer is divided by the grand total, which is 204, and the answer is 36.4. Then in the next cell, we have fish with condition factor greater than 1 present in pond number 1, and the answer is 38.09. And then in the next cell, we have fish with condition factor greater than 1 present in pond number 2, and the expected frequency is 28.31. And then in the next cell, we have fish with condition factor greater than 1 present in pond number 3, and the expected frequency is 38.6. So this is how we have calculated our expected frequencies for every cell. Now it is time for the analysis of chi-square, for the calculation of chi-square. So again, we have different columns in this table. The first column is about the different classes, different cells, and then the second column is about the observed frequencies, and then the third column is about the expected frequencies that we calculated in the previous table, and then the next column is about the difference between observed and expected frequencies, which is 35.91 minus 34 minus 35.91, and the answer is minus 1.91. And then for the next cell, which is the fish with condition factor less than 1 present in pond number 2, this is 25 minus 26.69, and the answer is minus 1.69. And then in the next cell, the answer is 3.6, and then in the next cell, the answer is 1.91, which is for the fish with condition factor greater than 1 present in pond number 1. And then we have 1.69, which is the difference between observed and expected frequency of the fish with condition factor greater than 1 present in pond number 2. And then we have minus 3.6, which is the difference between 35 and 38.6, and these are the observed and expected frequencies respectively of the fish with condition factor greater than 1 present in pond number 3. Now in the next column, we take the square of these differences between the observed and expected frequencies, and our answers are 3.6481, 2.8561, 12.96, 3.6481, 2.8561, and 12.96 for different classes. In the last column, we divide the square of difference between observed and expected frequencies by the expected frequency of the respective cell. So in the first cell, we have 3.6481 divided by 35.91, which are the values for fish with condition factor less than 1 present in pond number 1, and the answer is 0.1016. For the next cell, we have answer 0.1070, and then we have the answer 0.3560, and then the answer is 0.0958, and then the next answer is 0.1009, and the next answer is 0.3358. Now we take the sum of these values, and this will be our chi-square value, and the sum of these values is 1.0971. right? Now, the table values of chi-square for this test are 5.991 at probability 0.05, 9.210 at probability 0.01, and 13.816 at probability 0.001. And the result is there is significant association between culture system and condition factor of fish. Chi-square 1.0971, probability greater than 0.05. Now we move on to another question, and this question is about the population densities. So the long-term population studies indicated that among the common rodent species found in a village, 35% are field rats, 27% are house rats, 20% are mole rats, and 18% are pygmy mouse. Farmers of that village started using a rodenticide, which is the chemical which is used to kill the rodents. So they started using a rodenticide to remove nuisance rodents from their fields and houses. During the start of the 6th year of this practice, a population study was performed to find out whether or not there is a change in the frequency distribution of rodents, and following results were obtained. Field rats 30, house rats 35, mole rats 65, pygmy mouse 15. So this is our state of affairs. Now the question is, find out if the frequency distribution of common rodent species in the village has changed in 5 years since the application of rodenticide, or in other words we can say, find out if the observed frequency follows the homogeneous pattern of distribution. So here we have our chi-square calculation table. The observed frequencies are 30, 35, 65, and 15. The expected frequencies are 50.75, 39.15, 29, 26.1 for pygmy mouse. Then we have the difference between observed and expected frequencies for our 4 classes. So first one is 30 minus 50.75, which is the observed and expected frequency of field rats, and the answer is minus 20.75. Then we have minus 4.15, which is the difference between the observed and expected frequency of house rats. Then we have 36, which is the difference between observed and expected frequency of mole rats. And then we have minus 11.1, which is the difference between observed and expected frequencies of pygmy mouse. Then we take the square of these differences, and these are our answers: 430.5625, 17.2225, and 1296, and then 123.21. And then in the last column we divide the square of difference between observed and expected frequency by the expected frequency. So this is 8.4840 for field rats, 0.4399 for house rats, 44.6897 for mole rats, and 4.7207 for pygmy mouse. And we take the sum of these values, which is our chi-square value, and this is 58.3342. Now the table values of chi-square for this test are 7.815 at probability 0.05, 11.345 at probability 0.01, and 16.266 at probability 0.001. And this is our result. There is a very highly significant difference in the frequency distribution of common rodent species in the village after the application of rodenticide. Chi-square 58.3342, probability less than 0.001. So now our question number 6, which is about the same example that we saw in question number 5, that the long-term population studies indicated that among the common rodent species found in a village, 35% are field rats, 27% are house rats, 20% are mole rats, and 18% are pygmy mouse. And the farmers of that village started using a rodenticide to remove nuisance rodents from their fields and houses. So during the start of the 6th year of this practice, a population study was performed to find out whether or not there is a change in the frequency distribution of rodents, and following results were obtained. 28 for field rats, 40 for house rats, 41 for mole rats, and 36 for pygmy mouse. So the question is, find out if the frequency distribution of common rodent species in the village has changed in 5 years since the application of rodenticide, or in other words, we can say that find out if the observed frequency follows the homogeneous pattern of distribution. So this is the table for the chi-square analysis. The second and third column, they have the observed and expected frequencies, and in the third column we have the difference between observed and expected frequencies, which is minus 11.75 for field rats, 7.85 for house rats, minus 9 for mole rats, and 12.9 for pygmy mouse. And then in the next column we take the square of the difference between observed and expected frequencies of respective classes. So this is 138.0625, which is the square of minus 11.75, which is the difference between observed and expected frequencies of field rats. Then we have 61.6225, which is the square of 7.85, which is the difference between observed and expected frequencies of house rats. Then we have 81, which is the square of minus 9, which is the difference between observed and expected frequencies of mole rats. Then we have 166.41, which is the square of difference between observed and expected frequencies of pygmy mouse. Then in the last column, we divide the square of difference between observed and expected frequencies by the expected frequencies. So this is 138.06.0625 divided by 50.75, which are the values for field rats, and the answer is 2.7204. Then in the next row, which is about the house rats, we divide 61.6225 by 39.15, and we get the answer 1.5740. And then the next answer is 2.7931, in which 81, which is the square of difference between the observed and expected frequencies of mole rats, is divided by 29. And then we have 6.3759, which is obtained after dividing 166.41 by 26.1, and these are the values for the pygmy mouse. So we take the sum of these four values, and that sum is our chi-square value, which is 13.4634 in this case. Now the table values of chi-square for this test are 7.815 at probability 0.05, 11.345 at probability 0.01, and 16.266 at probability 0.001. So coming to our result, there is a non-significant difference in the frequency distribution of common rodent species in the village after the application of rodenticide. So chi-square is 13.4634, and the probability is less than 0.01. So this is all about the questions for the chi-square analysis.